Okay, so we'll continue to talk about sample standard deviation. And as we have mentioned, sample standard deviation has a different name, like another name, which is called the adjusted standard deviation. Okay. So these two are the same name. It's referring to the sample standard deviation. So what has been adjusted is we are in the formula, we are changing the denominator just a little bit. So in the denominator, we're using n minus 1 instead of using n. Going back to the example that we just used, we're going to change the formula just a little bit for the sample standard deviation s. Okay, you can have square root of the same numerator, which is 26, sum of square deviation, and then divide by 5 minus 1. Okay, because n in that example n is 5. So 5 minus 1, which gives you 4. And that gets you a square root of 6.5, which is 2.5495. This is the adjusted standard deviation, which is the same as sample standard deviation. Okay. We also notice that the symbol here using lowercase s for sample. Okay. So we have sample standard deviation, which is 2.5495 here. Okay. Now, sample variance here, even though the question doesn't ask us, but variance is the same thing that we did before, which is the number underneath your square root. So that's going to be 6.5 here. 6.5, and that's going to be the variance. That's the square of sample standard deviation. So 6.5 is a square, which is sample variance. Okay, so next let's see how do we compute the range and standard deviations for the data set in StatCrunch. For your homework assignment, whether in MyStatLab or in the other homework that you need to turn in, we're going to use StatCrunch for computation tool. So let's see these 5 data, 67, 68, 70, 72, 73. Okay, so basically you go back to the statcrunch.com and you can open an empty sheet. And this time we're going to enter these data 67, 68, 70, 72, 73 in the variable 2. Okay. And we're going to use the stat function here again. Just do summary statistics and then choose column because our variables are in columns. Choose columns. We're interested in variable 2, so move variable 2 over. And then by default, you have a lot of stuff being computed over here. But we can, again, choose the ones that you're interested in, such as the size, okay, and the mean. And again, using control-click. So size, control-click. And then we want to know variance, standard deviation, okay. And if you scroll down, you will see unadjusted variance. This is referring to population variance. And unadjusted standard deviation, that's also for population standard deviation. Okay. And then hit compute. And that will give you this output tab. Okay. So these two, as we just mentioned, the standard deviation and the variance, these are for samples. Okay, these two are for samples because they have been adjusted. And for the unadjusted variance and unadjusted standard deviation, these are for population standard deviation. Okay, these are unadjusted. And you can check what the question asks you. Okay, if the question says specifically this is a sample, then you should be looking forward to the variance and standard deviation, which has been adjusted. Okay, so a quick recap of the sample standard deviation and the population standard deviation that we have talked about so far. Sample standard deviation is adjusted in the way that the denominator is divided by n minus 1, sample size subtract 1. Population standard deviation is unadjusted, and typically we use symbol sigma for that. And underneath the square root, we are dividing by n. Okay. Now there's a guideline here, which one you use. Unless otherwise specified, when asked to calculate the standard deviation by hand, use the second formula, which is referring to the population standard deviation. Okay. And the variance and for sample and population is just the square of the standard deviation. And sum of squares is SS, that is sum of x minus m squared, which is the numerator and the square root. Okay, so that is SS. Okay, next we want to talk about relative standing of a data, okay, within a particular data set. The item we want to introduce today is called quartile. Okay, quartile is a number that's important for a data set, so we want to look at what quartile stands for. And I'm going to draw a graph just very simply to illustrate the idea of quartile. If you look at the definition, quartiles are measures of location. So it talks about the location of your data value. Okay. There are three kinds of quartile: first quartile, second quartile, and third quartile. They would divide a set of data into 4 groups with about 25% of the values in each group. So if we draw an ordered data set, this is the lowest value and the highest value. Okay. And we're going to say this includes 100% of the data. Okay. In the middle, it's going to be the value in the middle of the ordered data set. So that is our median, right? That we have learned before. Now, so we have first half, which is we also call bottom 50% of the data. And second half, which is the top 50% of the data. Okay. For this bottom 50% of data, we can again divide that into 2 pieces. Okay. So in here, in the middle, so this will be bottom 25%. And this is sort of the part that is in the middle, okay, but still to the bottom. Like this is another 25% of the data. And then keep going. You're going to have, this is another 25% of the data, and then another 25% of data. So each one rounds a quarter. So that's why it's called quartile. So if we say this is the lowest, that's the highest, this is medium, okay, and you see these 3 dividing points, okay, 3 dividing points. One is red, one is black, and one is red again. The first one we see here is first quartile, which is Q1. And the median in the middle is Q2, second quartile, and then the last one will be Q3, third quartile. So Q1 for the bottom 25%, and in Q3 separates the bottom 75% with the top 25%. Okay. All right, Q1 and Q2, right? So Q1 separates the bottom 25% from the top 75%, and Q2 separates the bottom 50 from the top 50. As for Q3, okay, Q3, it separates the bottom 75% from the top 25%. And for a data set, we can use a 5-number summary to summarize the spread of this data. Okay, the 5-number summary basically takes these 5 numbers. Okay, so 5 numbers, we have the lowest, first quartile, the median, third quartile, and the highest value, which is the max. So you have min, max, Q1, Q2, and Q3. Let's look at the following data set to find out the 5-number summary. Okay. With a simple glance of the data, you see this has been sorted. Okay, so sorted, you don't have to sort it again. So this 0.8 is going to be the lowest, which is called the min. So min, minimum value. 77.8 is the maximum value, highest. And then next, let's find the one in the right middle. Okay, in the right middle, let's move on to the next slide first for. So this slide has find out the min and max. Over next, we'll be finding the median. Okay, let's go back to here. So median will be in the right middle of your data set. And in the right middle, we actually have two numbers, right? 13.7, 14.1. So that will give us the median as the average of those two. So that tells us the median equals 1/2 of 13.7 and 14.1. Okay. Which will give us the median, which is 13.9. So if you do this, you're going to have 13.9 coming up as the median. And over next, we're going to find the first half, the median of the first half. So look at this first half and find the median. And median is going to be the value in the middle here, right? It's going to be this value, which is going to be 7.9. So that's going to be quartile, first quartile, Q1. So that's Q1. And then for the second half, which runs from 14.1 to 77.8, that's second half. Okay, let me use another color here. Maybe here, let's see. Second half covers these. And the one in the right middle will be this 21.5 based on its location. Okay, so 21.5 is going to be the third quartile, the median of the second half. So that's Q3. Okay. All right, so once you have found these 5 numbers, the min, Q1, median, Q3, and highest, you can put that in a number summary. Those are called 5 number summary. 0.8, 7.9, 13.9, 21.5, and 77.8. And based on the 5 number summary, we can get a graph which is called box plot. Okay, so box plot is a graph based on 5 number summary. And this is just one example of box plot that you can generate by using StatCrunch. If we go back to this question that we just looked at, okay, we would be able to generate the box plot by putting the 5 numbers on a number line. So we're going to use a number line, and you place those 5 numbers in their relative position. This is 0.8 and 77.8 as the min and the max. And Q1, 7.9, Q2, which is also the median. Okay, so let's emphasize this. So this is the same as median, Q2, and in Q3, 21.5, and maximum is way out there. So what we do is we put 2 ends, okay, at the min and the max. And we're going to draw a box that covers Q1, Q2, and a Q3, a rectangular box. And you're going to separate the box in the middle at Q2. So that's called a box plot. Box plot can give us some idea on the skewness. Okay, if it's not symmetric or extended more to one side than the other, then the distribution is skewed. Okay, we're going to use the last part of the video to talk about some of the box plot we see quite a lot, which is called modified box plot. Stay tuned.